Right, students, so we are back again and we're looking at the second portion of the lesson. So this time we're going to compare linear, quadratic, and exponential functions on tables. So what that means is we're going to use tables to determine if it's a linear function, a quadratic function, or an exponential function. All right, so let's just discuss briefly. A linear function. You can test whether a function is a linear function by the difference, finding the difference between the successive y values, all right, which is called the first difference. So the successive y value, we're trying to figure the difference out here. So we realize that if the first difference are equal, you realize that the difference between each term here, the first and second term, second and third term, third and fourth, they're all 3, so that makes this a linear function. All right, now we go to a quadratic function. You can test whether a function is quadratic by finding the difference between the successive first term, which now we call the second term. So we already know that this is our first difference here, right? So if the difference of the second, if when we take the difference of the first difference here, they're equal, they're all equal, we know that this is going to be a quadratic function. So the second difference of all of these are 10, so it's a quadratic function. And the third, an exponential function. We can text an exponential function by finding the ratio between successive y terms. So the ratio is here. How does it change? It multiply by 2, 4 times 2 give me 8, 8 times 2, 16, 16 times 2, 32, and so forth. So since the common ratios are all the same, then we know that this is an exponential function. All right. So let's go ahead and we're going to look at a few examples and take it from there. All right. So let's go ahead and we're going to look at this first example here. So on this first example here, the first thing that I'm trying to test for is I'm trying to figure out what is the common difference here. All right. So I want to see how does it change from here to here each time. All right. So the first time, if we have 98 and then we have 72, right? 98 and 72. So the difference here is 26. All right. Difference here is 26 because it goes from negative 98 to negative 72. All right. So now we're going to go from 72 to 50. All right. So if we go from 72 to 50, we have 22. And now if we go from 50 to 32, this is 18. All right. And if we go from 32 to 18, this is gonna be 14. All right. So we know that this is not a linear function because the first difference are not all the same. All right. The first difference are, if you realize these are all different numbers here. So what we're gonna do is we're gonna check to see if it's a quadratic function. So we're gonna check the difference from here to here, difference from here to here, and the difference from here to here. So this now is gonna be called, is what we call the second difference. So the difference between 26 and 22 is 4. All right, the difference between 22 and 18 is 4. Good. And then the difference between 18 and 14 is also 4. So each time the difference between each of these, they subtract 4 here. So we realize that the difference here is all the same. So this function is going to be a quadratic function. All right. Now let's look at one of these other examples here. So we look at the difference between first and second. All right. So remember, we can always check to see how does it change. Right. So by looking at this, I realize that this is a common ratio. Because if I say what's the difference, this is going to be 0.09, and this is going to be 0.08, and this is going to be 0.032. So I realize that each time here, they're multiplying by 2. From 0.18 to 0.136, they multiply by 2. Here also they multiply by 2. And here, if we check again, they also multiply by 2. So now it's not addition or subtraction anymore. This is multiplication. So because they multiply by 2 each time, I know that this is a common ratio. Once we hear the word ratio, we know that it's going to be an exponential function. All right, good job. So let's check this one now. So here, we multiply, we know that this is not multiplication or division, so this is not exponential, right? So now we can check to see how does it change from term to term, all right? So how does it change from 490? If we go from 490 to 360, it changes by what? 130, all right? If we go from 360 to 250, this is a difference of 110. All right. If we go from 250 to 160, it's a difference of 90. And if we go from 160 to 90, this is a difference of 70. So this is not a linear function because the first difference is not the same. So if we go here, we say, all right, let's check the second difference now. How does it change from term to term? Here, from 130 to 110, we know that this is 20. There's a common difference of 20. From 110 to 90, there's also a difference of 20. Good, things are looking good. So now we go from 90 to 70, this is also a difference of 20. So because the second difference here are all equal, I know that this is going to be a quadratic function. All right, so let's work one more from this. Let's work one more from this section, and then we'll go ahead and look at some software examples. All right, so let's look at this here. What's my common difference here? The common difference between the first and the second term is 4. All right, they subtracted 4. The difference here between these is also 4. All right. The difference between the third and fourth term is also 4. Starting to look good here. The difference between the fourth and the fifth term is also 4. So each time they subtract 4. So the common difference here, they're equal. So because the common difference here are equal, we know that this is going to be a linear function. So once you copy in the notes, I expect that you guys are going to do, this is number 4. And you're going to do number 6 as well. You're going to copy everything, but I want to check to make sure that you did number 4 and you did number 6. All right. So we have 7, 8, 9 here. So what we're going to do, let's check on this. All right. So now the first thing that I'm going to do here, I know that I realize that these are all fractions, right? So what I want to do is I'm going to make these where they all have the same common denominator, right? And once they have a common denominator, then it's easy for me to identify with this. All right, so remember we were looking at the y values here. So what I'm going to do is, I know, all right, the first one is 49 over 6. 6 over 6 is the same thing as, so we start 49 over 6. Then we have 6 over 6, which is 36 over 6. Then we have 25 over 6. All right. Then we have 8 over 3 with having a same, this is going to be 6 over 80 over 16. And then this would be 9 over 6. All right. So now I look and I realize that what's the difference? What's the difference from the first term to the second term? So I look, they all have a denominator of 6. So what's the numerator? It went from 49 to 36. So when I check here from 49 to 36, I realize that this was a difference of 13 over 6. All right. So now I'm checking here. Remember, this is my first difference. So when I check here, this is 11 over 6. When I check here, this one was 9 over 6. And when I check here, this one was 7 over 6. So my first difference here, they're not equal. All right. They're not equal here on my first difference. So what I'm going to do is I'm going to go to the second difference. All right. So what's the difference between these two terms here? I realize it is 2 over 6. All right. Here also, I realize that 11 and 9, so it's a difference of 2 over 6. And here also, 9 and 7, I realize that it's also a difference of 2 over 6. All right. So once I did that, I realized that my second difference, they're all equal. So since they're all equal, I know that this is a quadratic function. All right. So I'm going to leave this one for you, which is 6, 7. This is number 8. So you should do number 8 on your own. So let's go ahead and do this one. So what I realized that, right? Each time I realized that my denominator got less and less, right? So they divide, if I divide 32 by 2 here, what do I get? I get 16. If I divide, so each time it's divided by a half, all right? Each time it's divided by a half, so the difference from here to here, it's 1/2, all right? The difference from here to here is also half. The difference from here to here is also a half. And the difference from a fourth to there is also a half. All right. So because the common ratio here it's multiplied by a half, multiplied by a half. All right. Multiply by a half each time. Well, not multiply, divide by a half. All right. So each time it's multiplied by 2. So they divide by a half. Or if you want to say multiplication, that means you multiply by 2. Each time you multiply by 2. So that what happens. So I know that this is going to be an exponential function. All right. If you have any questions, feel free to come to office hours tomorrow, and I'll be more than happy to help you. Again, remember you have 2IXL, you have CC2, CC4. Make sure that you copy your notes the way it was described to you. All right. All right. Thank you. Bye.